For the next problem, we're given a scenario setup. We have two current carrying wires that are parallel with each other, and we are asked to find the B field at a point directly in between them. We're asked to find it at a point called P1, that is a distance d away, and at point P2, that is a distance 2d away from the first wire. We'll call this I1, we'll call this I2. Okay. So one of the first things we would want to do is actually identify which direction are the B fields pointing. So let's go down. I've kind of redrawn the diagram so it's a little easier to see. So we go down here, and now we have, I called this one is 1, right? And this one is 2. Okay, so let's look at 2. Because the current is going downwards, if we use our thumb to point along the current, we'll learn that the B field is actually curling around, and so it's pointing out of the page on this side. This B2 is pointing out of the page over here. That means that on the other side of the wire, it's pointing into the page. Okay, that means at P2, it's pointing into the page. So if we do the same thing for wire 1, we point our right hand thumb along the current and then curl our fingers around, and that shows us that the B field is pointing out of the page directly towards us on this side, and it's pointing into the page on this side. And similarly, on this side of this side of the wire, it's going to be pointing into the page. Okay. We're asked to find the B field, so we're going to end up using a principle of superposition. One thing that would be nice to know is what is the value of D. In the problem, it actually tells us that P1 is a distance D away, is a distance of 10 centimeters away from the wire carrying current 2. So what that tells us is D is actually 10 centimeters. So we're given that information in the problem. So that makes things a little easier. That means that in the middle of between these two wires, it's going to be D over 2, right? So D over 2 is 5 centimeters. And then likewise, 2D is 20 centimeters. So that will be very useful coming up soon. Okay. All right. So let's start. So let's find the B field in the middle at point D over 2, right? So let's go here. So we want B net is equal to mu naught over 2 pi. Then we're going to have, let's recall, we're going to say current 1. We're just going to go with the first one here, current 1. And at this point, it's pointing into the page. So we're going to go ahead and assign that a negative value. And since it's D over 2, it's 5 centimeters, or rather 0.05 meters. And then also, as we showed, this is pointing into the page, so that gives us I2, 0.05 meters. And we're told that the current is 5 amps, so this is 4 pi. Well, let's just write this down. Tesla meters per amp. 5 amps. And this is going to be a factor of 2 over 0.05 meters, right? So we plug this all in, and then we should get a value of 4 times 10 to the negative 7. Negative 5 Tesla, which we can rewrite as 40 microtesla. Okay, that's the magnitude of the B field in the middle, and it's pointing straight into the page. So into page. Because I'm giving a direction, we can keep this a vector. Okay, now let's find the B field over here at P1. Call this B net 1. So we have B field 2 is coming out of the page. That'll be positive, and it's going into the page for B field 1. That's negative. And this is going to be 10. This is going to be 20. So let's write it down. mu naught over 2 pi I1 over 0.2 meters negative plus I2 over 0.1 meters. Okay, so this gives us 2e to the negative 7 Tesla meters per amp times 5 amps. It's 1 over 0.1 minus 1 over 0.2. If you do this carefully, you can come up with a value of 2. Let me just double check this. Yeah, it's a positive value, so we have 5 microtesla. That's what we end up with. Okay, and so then B for 0.2, very similar, but now we have things a little reversed. So this is actually going to be 20 centimeters plus 10. That's 30 centimeters, and 20 for this one. It's positive for I1 and negative for I2. So then I1 over 0.2 meters minus I2 over 0.3 meters. And then plugging all these values in, we should get a value of 16.6 times 10 to the negative 7 Tesla, which we can translate to 1.66 microtesla out of the page. Right, I forgot to write this as a vector. This one was out of the page. And the very first one was into the page.